Moonshot AI dropped Kimi K3 weights last week. 2.8 trillion parameters. Free download. Open source. The internet immediately asked the same question. Can I run this on my laptop? I spent 3 days figuring out the answer, reading the model card, checking the quantization tables, following the GitHub threads, and doing the math on hardware costs. And the answer is complicated. So here is exactly what you need, exactly what it costs, and exactly why most of you should not bother. First, the file. 1.56 terabytes of weights. That is the full model at 4-bit precision, which is what Moonshot trained it at. They did not squeeze a bigger model into smaller bits afterwards. They trained it natively at 4 bits from the start. Quantization-aware training running through supervised fine-tuning and reinforcement learning both. So the file you download is the same precision the paid API serves you. That part is real and it is impressive. But 1.56 terabytes is not a casual download. It is not a movie. It is not a game. It is larger than most people's entire hard drive. The download itself takes 5 to 10 hours on a fast connection. And then you need somewhere to put it. Most consumer SSDs cap out at 1 or 2 terabytes. You would need a dedicated drive just for this one model. And if you want to back it up, you need another drive the same size. If you want to keep multiple versions, you need a small data center in your apartment. The minimum hardware to run the full model properly is 8 H200 GPUs. That is roughly $300,000 of hardware in a single box. If you do not have that, you are not running the full model. You are running a compressed version of it that behaves differently. The full model runs at 4-bit precision with a context window of 1 million tokens. The compressed versions trade accuracy for size, and the trade-off is steep. 1 bit is not just smaller, it is a different model that happens to share architecture. Enter the quantization ladder. Unsloth shipped a set of smaller builds that make this theoretically possible on less extreme hardware. 1-bit S at 594 gigabytes. 2-bit XXS at 711. 2-bit XL at 861. 4-bit lands at 1.51 terabytes. 8-bit is 1.56. Basically the original file. The smaller the file, the cheaper the hardware, but the more the model argues with itself. The 1-bit build agrees with the full model on 78.9% of next token picks. That means more than 1 in 5 tokens would be different. 2-bit XL gets that to 90.4. 4-bit is effectively the original. So your choices are accurate but huge, or small but wrong 1 time in 10. And wrong 1 time in 10 on a coding task means a broken build. Wrong 1 time in 10 on a medical summary means a lawsuit. So you could run the 1-bit version, 594 gigabytes. You still need 610 gigabytes of combined RAM and VRAM before it will even load. The 2-bit XL wants 880. For context, the highest-end Mac Studio tops out at 256 gigabytes of unified memory, and Apple quietly removed the 512 gigabyte option earlier this year. The consumer ceiling is now half of what the smallest usable build requires. You cannot buy your way out of this at the Apple Store. You cannot buy your way out of this at any consumer electronics store. You cannot buy your way out of this at most enterprise hardware vendors. Someone named GAA Media released a project called DeltaFin 2 days after the weights dropped. It runs on a 2021 M1 Max MacBook with 64 gigabytes of RAM. The measured speed is 14.6 seconds per single token, not tokens per second, seconds per token. 1 word takes about a minute. A short paragraph is most of an afternoon. The first version took 40 minutes per token. The current version is 82 times faster, and it is still unusable for real work. You cannot hold a conversation. You cannot iterate on code. You cannot draft an email. You start the prompt and go make coffee. You come back, and it has produced 3 words. You ask a follow-up question, and wait another minute for the first word of the answer. The developer himself calls it a research artifact, and not a practical chat setup. He calls it an existence proof and a testbed for streaming inference. That is the correct claim, and I respect the honesty. Most projects like this oversell. He does not. He says plainly that this is for researchers and experimenters, not for people who need to get work done. He says it is version 1 of a project that is 2 days old and the speedups are unglamorous and specific. A fused kernel that dequantizes MXFP4 and runs the matrix vector multiply in one pass. Neon on Apple Silicon, AVX2 on x86, an innate spine that halves the per-token I/O, a packed output head worth 17% on its own. Real engineering, real progress, not a product. Now the cloud alternative. Kimi K3 API costs about 1.5 cents for 1,000 tokens. The same 1,000 tokens that take 4 hours on a laptop arrive in under a second through the API. The math is not close. 4 hours of your machine locked up versus under a second for 1.50 pennies. If you value your time at minimum wage, the API pays for itself in the first prompt. If you value your time at anything more than minimum wage, the API is the only rational choice. If you value your sanity, the API is the only choice. So who should actually run this locally? 3 groups. First, researchers who need to inspect internal states or modify architecture. You cannot do that through an API. You need the weights on your own hardware. You need to see the attention maps, the expert routing, the latent states. You need to change the model structure and see what breaks. Second, organizations with strict data privacy requirements that cannot send prompts to a third-party API no matter how secure they claim to be. Government agencies, hospitals, financial institutions with regulatory constraints. Data that legally cannot leave the building. Third, people who want to fine-tune on proprietary data without uploading it anywhere. Trade secrets, patient records, internal documents, competitive intelligence. Everyone else is paying for a flex or wasting their time. If you are a developer building a product, use the API. If you are a student learning about large language models, use the API. If you are a content creator, a writer, a researcher without a $300,000 budget, use the API. Local deployment is not a feature for you. It is a headline for people who already own the hardware. It is a conversation starter at conferences. It is not a tool for getting work done. The weights are free, the knowledge is free, but the infrastructure to use them is not. And that gap between free weights and usable output is where most of the hype lives. The internet sees 2.8 trillion parameters and free download and imagines a ChatGPT replacement running on their desk. The reality is a file that needs a data center and a team of engineers to serve. The reality is that most people who download this will never get it to produce a single coherent sentence. The reality is that free weights and a usable product are separated by hundreds of thousands of dollars and thousands of hours of engineering. I looked into running this locally, so you do not have to. The short version is this. Download if you want to experiment or if you have a specific research need that requires owning the weights. Pay for the API if you want to get work done. And if someone tells you they are running Kimi K3 on their laptop, ask them how long they waited for the last sentence. Then ask them if they would do it again. Then ask them what they actually accomplished with those 4 hours of waiting. Then ask them if they have ever used the API and which one felt like the future. If you want a comparison of Kimi K3 versus Claude Opus 5, that video is next. Subscribe if you want more honest takes without the hype. That is the reality.